Welcome everyone, I'm Brent Testerman with CFM Company. In this video you will learn about override mode for fire, smoke, and life safety applications using the ABB ACH580 drive. Override mode is short for Fireman's Override Mode. This is a special mode in the ABB ACH580 that allows the drive to respond with priority to commands given by the building fire, smoke, and life safety system. During normal operation, regardless if the drive is in hand, off, or auto, activation of the override input will force the drive into override mode. The override mode allows the drive to run a motor at an adjustable frequency or a predefined frequency or a PID-controlled frequency in any direction. The use of override mode increases the safety for both life and property. The ACH580 features 7 override control options to meet the requirements of the system. The traditional preset fixed frequency is available. A normally open contact will close and override is activated. The VFD will run the motor at a single programmed fixed frequency. The drive can operate using a variable frequency control reference. A normally open contact is closed and the override is activated. An analog frequency reference is used, either AI1 or AI2. A volts DC reference or a milliamp reference can be used. In this mode, the ACH580 follows the frequency reference generated by an external controller. While this may be the same frequency reference that is used for a normal operation, it does not have to be. Note, while override is active, frequency reference cannot be provided through a field bus connection. The drive can operate using multiple preset fixed frequencies. There are 2 methods to select multiple constant frequencies. If there are no additional start interlocks or run enables used, the separate method allows up to 6 constant frequencies to be selected using 6 individual digital inputs. A normally open contact is closed and override is activated. This closed contact also activates override frequency 1. This contact remains closed to keep the override mode active. As events in the building change, the fire sequence can close additional normally open contacts to activate additional frequencies. The packed method uses binary counting to select up to 8 constant frequencies using 3 digital inputs. A normally open contact is closed and override is activated. The drive runs the motor at the minimum frequency, which is override frequency 1. While override is active, the fire control sequence can select between any of the 8 preset frequencies using binary counting. The drive can operate using floating point control. When override is active, 2 digital inputs are used. 1 digital input increases the frequency reference and 1 digital input decreases the frequency reference. The output frequency of the VFD will change as dictated by the 2 digital inputs. An initial starting frequency can be programmed. The rate of change is determined by a separate ramp setting, and the minimum and maximum frequency limits are programmable. The drive features a stop mode. When override is active, a normally closed contact will open and stop the drive from running the motor. Used on any driven equipment that must shut down during a fire event, such as a supply air fan, a return air fan, a makeup air unit, a general exhaust fan, etc. When the override stop command is active, the display will show override active in hand, off, or auto. The override text can be edited to provide specific detailed equipment information, such as fire shutdown. The drive can operate using a closed-loop PID control. When override is active, the frequency of the motor is controlled by the VFD's PID controller. The feedback signal will be hardwired to one of the VFD's analog inputs. AI2 is typically used. There are 3 separate methods to provide the PID set point. An internal drive parameter that is programmed for a specific set point. An analog input to provide a variable set point, typically AI1 is used, or by selecting from up to 4 unique internal set points using digital inputs. The override mode is triggered by a contact closure wired to a digital input from the building's fire alarm system. The digital input also acts as the start command for the drive in override mode. CFM Company uses DI6 as our standard input to activate override. When triggered, the drive enters override mode and ignores all other irrelevant inputs, including analog inputs, digital inputs, and commands sent over serial communications. The display of the control panel will show a message that the override is active. The hand, off, and auto keys on the control panel are disabled. When override is active, it is not possible to change any of the VFD's parameters through the control panel or through a field bus connection. When override is active, digital inputs used for start interlocks and run permissives can be enabled or ignored. For systems that have a standard day-to-day configuration and then change configuration for fire, smoke, and life safety operation, end switches can be enabled. Once the end switch is proven, the motor will start operation. If needed, a door interlock can be enabled and will prevent override operation. A freestat can be programmed to be ignored while override is active. A start interlock for a high duct limit can be programmed to be ignored and will allow the override to operate in a true run-to-destruction mode. During override operation, the ACH580 controls its relay outputs, digital outputs, and analog outputs in order to communicate its status to the Fire Control Panel, FCP, and to the Building Automation System, BAS. The relay outputs can be programmed for different functions to meet the status requirements of the local fire authority. As a standard for drives applied to fire, smoke, and life safety applications, CFM Company includes the optional extension card CMOD-01. This card adds 2 additional Form C relay outputs, RO4 and RO5, and 1 digital output, DO1. At startup, CFM Company will program the relay outputs to indicate a locked rotor, a broken belt, motor run status, and a VFD fault. In addition, if needed, a relay output is available to control a damper actuator. Additional VFD status can be given to the building automation system through one of the embedded field bus protocols, such as BACnet MSTP, or through an additional field bus adapter, such as BACnet IP. Although all commands over a field bus are ignored when override is active, the ACH580 will continue to provide status information to the BAS through a connected field bus. The override fault reset is programmed independently from the way restart attempts are executed during normal operation. The impact of a fault depends on its priority. Some faults will cause the system to trip, since ignoring these faults would lead to a system failure. Faults are grouped into high priority faults and low priority faults. High priority faults can be programmed to trip immediately, or can be programmed to a limited number of reset attempts, or can be programmed for an infinite number of reset attempts, which provides a true run-to-destruction function. High priority faults include overcurrent, earth leakage, short circuit, and DC link overvoltage. There are additional high priority faults not typically used with HVAC applications, including external temp 1, external temp 2, STO hardware failure, safe torque off 1, and safe torque off 2. All other faults are low priority faults. When the drive enters the override mode, active low priority faults are reset. All low priority faults are ignored while the drive is in the override mode. Low priority faults include DC undervoltage, analog input signal loss, motor over temperature, drive over temperature, panel loss, motor stall, underload, overload, supply phase loss, motor phase loss, overspeed, serial communications failure, external faults, and all other low priority faults. Note: a DC undervoltage, the loss of power, may force the motor to slow down or stop if it is excessive. Note: the AI supervision function operates for any of the override modes that utilize an analog input. Thus, if an analog input signal is lost, the drive will operate based on the AI supervision programming, which includes the ability to use a safe reference frequency. When override mode is no longer enabled, the drive will return to its original operating state before override mode was activated. Any external interlocks which might interrupt the operation of the system during normal operation will return to active status. If the system was running in auto and the start command from the BAS is active, the drive will return and run in the auto mode. If the system was running in hand mode with a local frequency reference, it will return to the off state and will require that the hand button is pressed to return to local operation. If the system was in a faulted condition prior to the activation of override mode, the fault will initially be cleared. If the same fault occurs again, the fault will be active. While override mode is most commonly used for fire, smoke, and life safety applications, it can be used in any application that requires an override function. For example, an exhaust fan connected to a chiller room with a refrigerant monitoring system, or an exhaust fan connected to a parking garage with a carbon monoxide monitoring system, or an emergency forced air fan for a room with a low O2 sensor. Need more information about override mode? ABB has published an application guide. Simply search for Application Guide, ACH580 Override Mode, and download the full PDF document. If you have additional override questions, application questions, or ACH580 drive questions, please contact CFM Company. Thank you for watching this video. Visit us at cfmcompany.com to learn more about each of the manufacturers we represent.